This is Anthony Santosh, Assistant Professor in Chemistry. Now we are going to discuss about one component system. In this topic we will be discussing the phase diagram of the values between temperature and pressure. So it is a compressed graph. Let us go into the topic.
Let us discuss the phase diagram of one component system taking water as the example. Okay, in this curve, in this graph, we have different areas. There are three areas. One is AOB. Below this line, the area AOB, we have water vapor, and above this area of AOC we have H2O liquid, and within the area of COB we have water solid. So here we have water solid ice, here we have water liquid, here we have water vapor, and in this graph we have all the datas. So in order to get all the datas, we have a compressed graph. This graph is not to scale. This graph is prepared compressed to have all the datas, and we did not draw this graph according to the scale. Okay, now let us discuss the details present in this graph. Now we have three important curves and another one curve. What are all the importance of the curve? Along the curve OA, we have an equilibrium between H2O liquid and H2O vapor, and along the curve OB we have an equilibrium between H2O solid and H2O vapor, and this OB curve is called sublimation curve. And along the curve OC, this is giving us the equilibrium between H2O liquid and H2O solid. So these are the three important curves which gives us the data or details about the three equilibriums possessed by water molecule. And at this point, triple point, which is called a triple point, where we have all the three phases at equilibrium. What are the three phases? We know H2O liquid, H2O solid and H2O gas. All the three phases of water at equilibrium only at the point O, which is known as triple point. Okay, and we have so many details, other details. Let us discuss about one by one. Okay, so at the point from the point triple point O, we have another one curve which is called metastable equilibrium, OA dash, which is called metastable equilibrium. So what is metastable equilibrium? We can have H2O as a liquid below its freezing point by keeping water as a liquid. So we know 0 degree Celsius is the freezing point of water, and with due care, by removing the formed crystals of water, we can have an equilibrium between H2O liquid and H2O gas along this curve of OA dash, and this is known as metastable equilibrium. Clear? Okay, so now I want to revise the points. That is, one is area AOB. Below the area curve of AOB we have the area of H2O vapor, and within the area of AOC we have H2O liquid, water liquid, and within the area of COB we have H2O solid. And we have three important curves. One is vaporization curve, and along the vaporization curve we have H2O liquid is in equilibrium with H2O gas, and along the OB curve, sublimation curve, H2O gas is in equilibrium with H2O solid, and along the OC curve, which is called fusion curve, we have H2O solid is in equilibrium with H2O liquid, and along the curve OA dash, which is called metastable equilibrium, which gives us the detailed value of the formation of H2O liquid with gas below its freezing point, that is 0 degrees Celsius. Okay, and now we are going to discuss about the datas of vaporization, fusion and sublimation, mainly the degree of freedom value. Okay, for this consideration, for this H2O phase diagram, we have to use the Gibbs phase rule of normal form. The Gibbs phase rule is F equal to C minus P plus 2, and F is degree of freedom, and C is the number of components, and P is phase. Okay, and using the values of substituting the values, we can find out the number of degrees of freedom. In another video we will discuss the detailed basics of degree of freedom, component and phase, and here I would like to explain how to calculate the values along the curves and in the triple point. Okay, now let us see those things, and we have to use the normal form of Gibbs phase rule, that is F equal to C minus P plus 2 here. Okay, now we have to consider OA curve, vaporization curve, and we have that here, vaporization curve along the OA curve, how we have to calculate the F value, degree of freedom value. So along the OA curve, we have H2O liquid is in equilibrium with H2O gas, and we know along the H2O liquid and H2O gas curve, that is vaporization curve, how many components are here. So this is a one component system, so we have to substitute in the formula F equal to C minus P plus 2. We have to substitute the number of components as 1 minus number of phases. Here we have H2O liquid and gas, so 2 phases, so minus 2 plus 2. So finally we will be getting F equal to 1. So if the number of degrees of freedom F is 1, it will be termed as univariant. So this system along this curve is univariant, that it has number of degrees of freedom value as 1, it gets as 1, so it is called univariant. And in the curve of OC curve, that is fusion curve, in which we have H2O liquid is in equilibrium with H2O solid, we can see that in the graph. So OC curve, so along this curve we have H2O solid and H2O liquid is in equilibrium. So we can substitute the values here. So F equal to C minus P plus 2. So the number of components here is 1, number of phases is liquid and solid. So 1 minus 2 plus 2, so we will be getting F equal to 1 here also, so that we can say that the degree of freedom is 1, so it is univariant, the system is univariant. And along the curve OB also, the sublimation curve, we can get the value as 1, the number of component as usual 1, the number of phases here solid and gas, so 1 minus 2 plus 2, so F equal to 1, it is univariant. Okay, so along all the curves of water system, vaporization, fusion and sublimation, we are getting the degree of freedom value as 1. So along the curves the F value is 1, so it is univariant. And now we have to go to the important point, that is called triple point, where all the three curves are meeting. So OA, OC and OB, and all the curves are meeting here, and at this point all the three phases of water are at equilibrium. Okay, so So H2O liquid is in equilibrium with H2O solid, which is again in equilibrium with H2O gas. So now we have to substitute the value F is equal to C minus P plus 2 here. So number of component again is 1, number of phases 3 plus 2. So 1 minus 3 plus 2. So F is equal to 0. It is invariant. Okay, F is equal to 0. So the system here is invariant, which means there is no degree of freedom at all for the system. So there is no, since there is no degree of freedom, F is equal to 0. Now OA, that is metastable equilibrium, and now we can consider the value of areas from any one area. So now I have given here 3 different points, that is point X, and here also I drawn point X, here also I have placed point X. So we will be getting the same value in all the point X. Okay, so I put in the areas, from the areas, not along the curves, from the areas I would like to find out the degree of freedom value. Okay, now so here we have point X. If we consider point X, F is equal to C minus P plus 2, and number of component we know it is water only, so number of component will be 1, and number of phases in any one point, X, so number of phases will be 1. So and number of degrees of freedom we will be getting F is equal to 2. Since F is equal to 2, the system is bivariant. It is called bivariant. So what does it mean, bivariant? So along this curve, the point X can have one temperature value and one pressure value. From this point, within this area limit, I can change the temperature as well as pressure. So 2 variables I can change. Both the variables can be changed. So I have 2 freedom within this area. I can move here and there, so that the area or the number of phases or number of component will not change. Okay, for this case also, from this point X, within this area of COA or AOC, I will be having the equilibrium, or the number of phase will be liquid, water liquid, and within this area BOC, water solid will be present. So there will be no change in the phase. Okay, but when I take any one point in this curve, or in this curve, I will be having 2 phases. So if I want to change the temperature or pressure, I can increase from here. For example, if I want to increase the temperature from here to here, I can change the temperature, but the pressure will be changed automatically. Okay, so if I want to decrease the pressure, means I can decrease from here to here, but the temperature will get changed automatically. So the temperature, for every temperature value there will be one pressure value. So I will be having only one freedom. I will get the F value as only one. I can change either temperature or pressure within the curve, but the other variable will get changed automatically. Okay, so I have only one freedom. But in the case of triple point, what is the condition of triple point? At a temperature value of 0.0075 degrees Celsius and the pressure value of 4.58 millimeter mercury, we can have all the 3 phases of water at equilibrium. But if I change the pressure value, or if I change the temperature value, I cannot have all the phases of water at equilibrium. Only at the temperature value of 0.0075 degrees Celsius and the pressure value of 4.58 millimeter mercury, we can have the equilibrium of H2O liquid, H2O solid and H2O vapor. If you change the pressure value, it will be diminished. And also if I change the temperature value, I cannot have the equilibrium of all the three phases. So there is no freedom at all at the triple point. So the F value for triple point is 0. Only at that condition I can have all the three phases of water at equilibrium. Clear? So these are the equilibrium conditions, and these are the areas of different phases of water, and these are the equilibrium along different curves. Okay, let us discuss other things in the next video. Thank you. So what is critical pressure and what is critical temperature? Above this temperature value, we cannot have H2O gas. That H2O gas cannot exist above this temperature value, and H2O gas cannot form any equilibrium with other phases. And above this pressure value of 218 atm, we cannot have H2O liquid, and H2O liquid cannot have any equilibrium with other phases of H2O solid and H2O vapor. So H2O water cannot exist and cannot have any equilibrium above this pressure value of 218 atm and above this temperature value of 374 degrees Celsius. So these values are known as critical temperature and critical pressure, and these are the details of different curves, points and areas of water system. Thank you.